Hello everyone, welcome to this webinar. My name is Guido and today we are going to cover the MDX formulas. The reason why I made this webinar is because there are a lot of MDX functions available, but there is only a list of them that I am using, and with these functions I have solved all of or most of my problems that I have had, or made solutions with these functions. And I want to save time for you, so you don't have to go through all of them if you want to find a solution. I'll give you the ones that I am using. This is the list of the functions that we are going to be covering today. And why? Let's start with the question, why to use functions? And the reason is to simplify and broaden the scope of MDX queries. With functions, you can do things or make solutions that you wouldn't be able to use without them. And it also can save you time and just simplify things for you. In the previous webinar, we covered a little bit about function usage, and I'm just going to repeat that for you right now. And the basics are that functions take specific values and they return specific values. Right? Functions take something and then they do their operations that are specific to each function, and they return something. And functions can be written in flex.bi in two ways, or there are two syntaxes for functions. One is using a dot and then the function name. The other one is using the function name and putting what it takes as parameters for the function in the brackets. In the first case, the function takes what is before the function. So we can start off with the previous member function, and this was the first type where the function uses the something what is behind it. And we are going to start with the simple and basic functions, and then we are going to move on to more complicated or complex ones. So stay tuned. I have prepared functions here to show you how each and one of them works. We had we had the previous member function. This is what I wrote in flex.bi. I also use the name function, which returns the name of the member. And here I use the time dimension. I have it here in rows. So in this case, you can see that the previous member function returns the previous member. We have in the row we have October, but since September is the previous month, it's going to return the previous member. This also applies for other dimensions as well. You can use it per day, for days, and for years, and so on. And this is an example where this function is used. We have, and I'm showing all of these this MDX in our templates account, so you can go ahead and find all of them after the webinar there as well. And here is one of the functions I have used, the previous member. Looking at the MDX, what it does, it takes the item base amount, and it's going to be the base amount for the current member or the current time period, and it subtracts the last period item base amount with this function. That means that we can get an increase how much the item base amount from the last month in this case, right? So we have October here, from April to October, we have this amount of increase, and we can also do other things with this function, like we can calculate also the increase percentage, like it's done here. Next functions, the current member and the default member. And the current member, I talked a little bit about it already. And the current member returns the current member. In this case, I'm trying to get the name of it, but you can also you can use it for different measures, you can combine it with different dimensions, and so on and so on. We will have this current member in more examples later, because it's widely used. So current member gets current member, previous member returns the previous member. Default member. I'm getting the name of the default member here as well. Default member and its name. And default member is going to be always the first member from the dimension. In this case, it's all times, right? So it's going to be all times. If I would use it for customer dimension, it will be all customers, for example. If I would do it for items, it would be all items. Where to use it, you can as well from templates account. And it was profit from total. You can see here what it does. It calculates how big is the percentage that this supplier or customer has brought us profit. So all customers brings us 100% profit, and each one of them, for example, this category gives you 55%, this customer gives you 4% of the profit, and so on. So here, what I did, I took the current member from the customer dimension, took the gross profit, so this is a tuple, and divided it by the default member, what would be the all customers' gross profit, to get the profit percentage. Next, three functions. Aggregate. If you have created reports in flex.bi, you probably have used this function already. Here I have made a very simple set from 3 time members, and I've just returned the item base amount of all of these 3 members. So it takes a set and a numeric expression. In this case, the numeric expression is the measure item base amount, and the set is the one that I've written here. So this is a syntax how to write a set in these kind of brackets. And September, October, November 2016, I have selected them in September, October, November here in the report as well. You can do the math, but it aggregates them together and gives the sum or item base amount. Yes, it does the item base amount of these members and date member. So we have the current member that we looked at previously, and we have current date member that we are looking at right now. Sometimes I hear people mixing those up, so I want to clarify that the current date member returns a date from the machine that flex.bi is running on, or the actual real-time life. In this case, since we are in August, the current month is August. If you look at the calendar, it's going to return the August. That's for current member, it checks what we have in flex.bi. So we see here in the rows, it's September, so it's going to return the September. But the current date member, it doesn't take the time dimension into account, it just checks the real time. And I also have specified that I want to see the current month. That is also important for this member. And I've returned its name so that we can understand here. Next one, lag. This is very similar to previous member. We had this one previous member. And I've seen a MDX query where a person had written like 12 times previous member so that he could return the month 12 months ago from now, right? And for this purpose, you can just use the lag function. And here it's going to return the name of the time that is three members previously. In this case, since we are in months, then it's going to be 3 months previously. So if I check December, 1, 2, 3, then it's September, and we can see that it's also September. Before December, 1, 2, 3, September to 3 months back. Here you can see an example of how it could be used. And in this example, I'm going to explain how it works, is that we take this function would return the average amount from the last 12 months. And the way it is done is by making a set starting from 12 months ago. So we take the times months current date member. So it's going for today, it would be the August, and return the month 12 months ago. And this makes it also include everything in between. So that will make it from August last year to August right now. So, and this aggregate function calculates the item base amount, what is the numeric expression, and divides it by 12, because we always know that it's going to be 12 months before this month, or 12 months, yeah, 12 months before this month. Next, 3 functions: count, filter, and members. So what count function does, it counts how many members are in a set. So it takes a set and counts how many members are there in a set. Right here, I have specified a simple set that I used before, and I will use it again, where I took the same 3 months and I returned the count of them. And since we see that there are 3 members in this set, we know that it's going to be 3. So it takes a set and returns how many members are in a set. The next function is filter, and this, so it's going to return two members. What I did, I took the same count function, I took the same set, but this time I added a condition. And this condition checks if the item base amount for this month, and this month is bigger than 50,000. So it goes one by one. And how it works is that it takes the first month, it checks if the item base amount is bigger than 50,000, If it is true or it is bigger, then it will include in the set that it will return at the end. If it does not match this condition, or the item base amount is smaller than 50,000, then it just throws out this member from the set. And if I check the item base amount for these 3 times, then we can see that September does not have 50,000. It has less than 50,000. So this member will not be included in the set. And we can see that there are only 2 members. So this is correct. Next function, members. Okay, I created the members function in the customers dimension that I have selected in the pages right here. And this is how it's going to look. What I did is I also had to aggregate, because this function returns a set, and as we know, I'm going to show you right now. If I would return it like this, then I will get an error that, hey, it must not be a set. That's why I use just an aggregate function to get all of the members from the category, the customer's category level. You can find the category level here, hierarchy levels, and you can use the members function for these levels. So the function returned all of the customer categories, and if I check it, then I can see that we have the 1, 2, 3, 5 categories, and it goes the same for all customers. So I got all the categories. This can be used and is used in one of our sample reports in the templates account, customer segmentation, and it's used to sort out customers into groups, into a small group where customers have less than 50,000 item base amount. If they have medium base amount, they have large base amount. So segmenting customers. And it's the same principle is used here. Here we have the larger than 60,000 example, where we count all the customers that have the item base amount bigger than 60,000. So this is the set, all the customers, and this is the condition, if it's bigger or equal than 60,000. The same or similar manner, the small is used, then slip less than 50,000, and the same or similar manner, medium is used. This time there are 2 conditions with an and means just that both of them have to be true in order for this customer that we are filtering to be included into end result set. Next, we covered the current member, so I'm going to skip that. And now we're going to talk about the average and descendants. Let's close this and go to average. For this average, I took the same set of these 3-time members, and I specified that I want to see the average item base amount. And it just returned the average base amount. Sum these 3 together. Let's do this. Sum them 3 together and return the average of these 3 times. And here, as you can see, it takes a set that was these 3 time members in this case, and also a numeric expression, and returns the average of these all of these set members. Descendants that I have defined here because I want to expand it. That's why I also aggregated, because the descendants function returns a set. And what I wanted to see from this set is these categories. This is a customer category, I wanted to see all the customers in this category. This is what is specified in the descendants function. You need to specify a member and a level. So the member is for which member, in what level we want to see all the members. Here, so this customer category, all the customers from this customer category. If I check it here, first let's see this category. We can see all of these customers against trading code, new imports, so on. And if I check the descendants function, we can see that these are the same customers and only those from this category. So this is how this function works. It can, if you would specify, for example, a year, a specific, like let's say year 2017, and you would specify a level day, what you can do, it will return only all days in this year, because usually the time dimension is here is in hierarchy where it starts with the year, then goes quarters, then months, and then days. If you want to see only days for this year, then you can use this function, and there won't be any quarters or months in between. So this is how it's useful. This is an example where it is used, everything combined, average GP this year. Let's see, average customers, average GP this year. How it, what it does, it takes all of the months in the current year that is specified into the time dimension, and it's going to be the current year, and for this current year it returns all the months, so it will return from January to August, but since we don't have any date, if we don't have any data for September, October, November, it will not return those. And then it puts it into the average function, it returns the average. If we just took all of the, let's say if we took the gross profit for this year and divided by 12, it would not be correct because we don't have 12 months. We only have months till August. So with this function, we can also know how many months are there. We can get the gross profit for all of the months, and then we can do the average for this. Now we are going to go into dates and date times a little bit. And I'm going to show you a little bit how the workdays function works. So this function takes 3 parameters, and as we learned into at the previous webinar, the date time means basically a string that represents some kind of time. So here I made an example where it took 7 days ago, which flex.bi can translate into a time and I can understand. I took now, this is also time, that will return the time right now. And I also excluded this. So how this works is that time diff work days calculates how many days there are from 7 days ago till now, excluding Saturdays and Sundays. So this means Saturday and this means Sunday. If I would do 5, it would also include exclude Fridays. So since we know that in every week there are only 2 Saturdays and Sundays and so on, we can guess that the function is going to return 5, and it's always going to return 5. Because in every week there's 5 days to work, and so on. Start date. The next function we're talking right now about is start date. Here we can see that it's September 2016, but this function returns also the 1st of September 2016, and this is what it does. It takes a time member and returns the smallest it returns the first day of the member. Or I wanted to say the smallest member, but the smallest member is day, so it's just going to return the first day. In similar manner works next start date, where it returns the next member's first day. So the first day in October is going to be the 1st of October 2016. October. The current date member we covered already. And this is where the function is used in target monitoring forecast for a person. Unfortunately, we are in the 31st of August, the last day of the month, so the forecast is going to match the gross profit. So I won't be able to illustrate as good, but I want to show you the logic. Here this is not one function, these are 3 functions and they work together. We can see, I'm going to switch to table, and this is the forecast for the month or the person. And if I check this function, it uses period working days and average GP per day in period. First, let's check the period working days. Period working days here. We can see it takes the current member, that is the current month, checks what takes the first day of the member, takes the last day or the first one from the next month, so from start of this month till end of this month, and returns how many Mondays, Tuesdays, Wednesdays, Thursdays, and Fridays are in this time period, right? And in this function, it multiplies it by the average gross profit per day in this period, right? So let's check how the average works. And the average, what the average does, it takes the gross profit base amount that we have until now and divides of how many days, how many working days have been until today. So if a person has worked 5 days this month and he has some kind of gross profit, this will divide the gross profit he has right now by 5 period working days until now, until today. And you can see it takes from the start date of this month until now. and returns how many working days are. And in summary, it will take, for example, a person has worked 5 days, he has gross profit. So this, what this function will do is it will calculate the average of the 5 days. It will divide the gross profit by 5 and multiply by how many days are still left, or how many days are all together in this month, to combine what would be the total forecast for this month. I see we have a question, 2 questions. Do you have to exclude Saturdays and Sundays if only uses working days? I think we can answer that by, let's go here. So it takes a string, the third parameter is a string. These days will be excluded from the day count. So I could also remove these if I want all days. Will this work? Okay, yeah, so you see it works. It returns 7 days. If I want to exclude Monday, I would exclude Monday. I want to Wednesday, then it would exclude Wednesday. So this is how it works. About holidays that are not on Saturday or on Sunday, so there are multiple options. One of the options is that you can do a Excel file where you have all of the dates that should be excluded, and you could map them to the time dimension. So you can upload a file that's going to contain all of the holidays, and that would, in source files, an Excel file, and that would exclude the holidays. And talking about this same topic, we are right now working on a import from Hansaworld where this could be imported automatically. Those are 2 options, and the third option is to create a calculated member, and the calculated member will simply go case when time current member matches. Then you specify January 2006, for example, 1st January, no, it's good here, January 1st, 2016, 17, and then -1 or something like this. And this way you can specify all of the copy and paste January 2nd, December, or whatever. You can copy and paste all of these dates that you want to exclude, and use this as a calculated member or filter to filter these this time. So this is the overall idea on how this could be done. If you have more specific questions, then write us at support@flex.bi and we will try to help you. So this is the GP forecast. And one of the functions I've already showed you, but that is name, and I've used it a couple of times to show you illustrate the name of the members. And this is one of the ways I use this name function, is to debug, to see what do I get as a return when I'm writing MDX. And also we have level function, and what level function does, it returns in what level is the member, is the current member. So this I have written a query that checks what level we have, what's the level's name for the time dimension. There you can see it's a month, but if I open it up, then it's a day. So it returns the name. This function returns the name of the level. Also specified name. You can also do different things, not just get the name. The current member we covered already. Then the next example is going to contain more than 3 functions, so we put it in 2 slides. And let's talk about the get property now. So every CV doesn't show anything. This is because I have not selected a customer. If I select a customer, it's going to show you this. And this function contains this, and I will get the street from the current customer. I have put a link here in the presentation to our documentation, where you will be able to see all of the properties available for every dimension and every cube. Let's check something, primary contact, for example, here. I am here in documentation. I can see that there's a property primary contact, and if I change that, if I would change this to primary contact, it will return the primary contact. And as I mentioned before, this is the list of the members that are available, and if you put any of these names, then if you have information in your Hansa-Vault, then you will be able to see the data on this member, the specified data. Parent function. We get the parent. We'll talk about the parent function. I will give you an example to cover all of these. I've just taken the customer parent's name. That's what I'm returning right now. So the customer dimension, its parent's name. In a similar way where the sentence function took some kind of level, what parent function does, it returns what is above the current member. Right? So since I have the customer dimension specified here, it's going to return the parent of this customer against all trading call. Its parent is credit customers, so that's why it returns this. So if I select this, then it returns all customers because that's his parent. If I take something from cash suppliers, then you can see that it returns that its parent is the cash supplier category. Putting it all together, there is invoice due date property, and I want to return it. So I'm going to remove this for demonstration purposes. And so this invoice has invoice due date. But if we check the invoice item members or this level, then we can see that we don't have no invoice due date for this member. But with the MDX, we can see that I also get a property for items, for invoice items. And how it is done is like this. So this function checks what is the invoice's current member level's name. So if it's an invoice, then it's just going to return the property that is the invoice due date. We check invoice, then we see that there's a property due date here. Oops, sorry, here. But if it's the invoice item level, the level is invoice item, then it's going to get the parent's due date because the items don't have this kind of property. So with this query, MDX query, we can get the due date not only for the invoice, but also if we are looking at the invoice items. Okay. Sum and previous periods. Sum function is the same as aggregate function, with only one difference is that, for example, I had aggregate here. If I change it to sum, so as you can see, I change it to sum, and now I cannot expand it. I don't have a plus sign, and I cannot expand or check what's in the list. So this would be the difference. If I put it back to aggregate and apparently turn it off and on, then the plus sign is back and I can check what's inside of the sentence. So that's the difference between aggregate and sum. And let's take the customer that I had before, and you can see here I did exactly the same as I did in the aggregate function. It returns the same. Previous period is an interesting function, and I will need a little bit more space to demonstrate this. What I simply did is I used another function for debugging, what is not named set to string. This function I have not mentioned because I use it only for debugging, and I have mentioned it, though I have mentioned it in the previous webinar. So what this function does, it takes a set and returns it as a string so that I can read what kind of strings are, what kind of members are in a set. And I wanted to see what kind of members would this previous periods function return. And the previous function, in this case, took the current time as a parameter. So if I activate, this is what we get. We get a set of members. It's a set because we can see we have the brackets here, and we can see the commas. So this is one set member, this is another set member, this is another set member. And to show you, to make you understand a little bit better about this function, I will put the time dimension here so we can compare. And if we check this September 2016, sorry, 2017, September 2016, this will be the member. So the idea of the previous periods member is to return all times that were before this time member. So in this case, return everything that is before September. Right? In order to do that, if you look at it here, then if you want everything from September, behind the September, then we cannot return the third quarter, because then the September would be included. And this is not what the function does. It returns everything before it. So we have to aggregate August and July. And we also cannot return just the year 2016, because then the fourth quarter would be included. So everything before September is August, July, then the second quarter 2016, first quarter 2016, and then all of the years. If we check here, then we get August 2016, then 2016, then July 2016, then the second quarter, the first quarter, then year by year by year. This is exactly what I showed you here: August, July, quarter, quarter, year, 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 year. So if you want to know information on everything behind today, then you use previous periods. We talked about current member already. Then there are two other interesting functions here. One of them is cascading children set. This is a very specific function. I haven't used it a lot, but I believe that there could be situations where this is useful. In this case, I took the member that I created in the customer dimension that is called descendant. Just to remind you, it was this one where we took all of the customers from the customer category, from this customer category, credit customers. And we aggregated them together. That there might be cases you don't want them aggregated, but you want to get the set because aggregation puts together into one value. It puts it together in one value, but if you want to get a set from that, you have to expand it again. You have to open up the set. And this is what cascading children set does. It opens up the set. So in this case, it would open this set and count how many members are in this set. And we can see it's 19 members. If I check the descendants here, you can count it later. I counted it and it's 19 members in this set. Item. I return the name again because if I had not put the name, it would return just a number that will be invoice amount, and it would not be so easy to understand. So I always use name for this presentation. The item function, what it does, it takes one member from a set. So if you want to get the first member, the last member from a set, you want to get the third member or specific member, only one from a set, then you have to use the item function. In this case, I wanted to return the first member from a set, and the first member in a set is the 0th member. This comes from programming. You have to just remember it. Then the counting starts from 0. In this case, the 0th member is September. So I have a set and I want to get one member, then I use item. Putting it all together. This is one example that we made for a customer. And I'm going to show you this one. There's some little bit more information there, but it does not change a lot. So the situation was that the person wanted to know the current cost of the stock. So we are switching right now to stock queue, by the way. Forgot to mention we are in stock queue. And the customer wanted to see the total cost right now that is in the stock. The total cost right now that is in the stock. But since we are the calculated members, total cost in, total cost out, just show the differences or what happens. So what kind of cost goes out from stock and what kind of cost comes into stock. Right? It does not show the current stock. So we made a calculated member that will take all of the changes from the stock, sum them together to get the current stock. This is why the previous periods is used. So I want to know what has come into stock and what has come out of stock in the past. And this customer had some special fiscal years. And because he had 1 year, untraditionally, he had 1 year. So fiscal year, if we created the fiscal year with this function here, then it will not match their fiscal year. So we had to calculate the members for every fiscal year they had. And since those were aggregated calculated members, I had to somehow get the first time or the first period from this set. So that's why I had to use the cascading children set. And I wanted to get the first item from that, right? So the plan was that they have a aggregated set, for example, April 2016 to March 2017, they have just a set. And I wanted to get the first month from the set so that I could use it for the previous periods we talked before. So previous periods took just one member. So in order to get it, I had to use, again, the cascaded children set. I opened it up. I opened up the current, so this was the fiscal year. I opened it up with cascading children set. I took the first member from the set, and then I checked all the previous periods. I summed it all together. I summed all the costs in and the costs on all together to get the current stock. I hope this is clear. Might be a little bit confusing. I can do just simplify it a little bit. Maybe you understand better. So this is more how it works. The time current member was the aggregated fiscal year, and I opened the setup. I took the first member from the set and gave it to previous periods so that I can get all the previous periods for it. And this is just so that it does when the fiscal year is in the rows. So this function will do it. I hope that was clear enough. A very tricky situation. Somehow with these functions I managed to do it. I'm not going into all of the members here. It's kind of complicated. Just wanted to illustrate how you can use the functions. So here we have talked about filter already, and we have talked about filter, and we have talked about members already. Let's talk about order function. I use the set to string function for illustrative purposes, and I took the same set with the 3 months, and I want to check the item base amount. So what the order function takes is a set. It takes a numeric expression that it's going to order by. So it's going to order by the numeric expression. It's going to compare which expression is the biggest or the smallest to sort them. And the third parameter is ascending or descending. It's a string. In this case, this is the set. This is the measure, and not string, but a value. And I said that it has to be ordered in descending order. And here we see that October is the first one and it's the biggest one. The next one is November, it's the second biggest one, and September is the third biggest one. This is September. So it ordered all of the members by its item base amount. Non-empty cross join. Non-empty cross join takes two different sets and then creates tuples for those members that have values in between them. Here, in this example, I have the same times, the 3 months, and I have also taken a set with this customer category and with the none category. And this function will take this time member, and it will try to combine it with this category. It will check if there is any values in between them, and if there were, they will return them as a tuple. So it will check this time with this customer, then this time with this customer category, then it will check again this September with this none category, then October with this none category, and so on. It might do it in different order that I mentioned, but you get the idea. Now we can see that it's a set because of these brackets, and there is opening bracket, and it closes here with a comma, and this is definition of a tuple, right? So it turns a set with tuples. As I mentioned before, it combined the September with this customer, then took October with this customer category, and then November with this customer category. But we don't see nothing from the other non-category. And we don't see anything because the non-category does not have any values in between them. So it did not include this. Maybe it's important to notice that non-empty cross joint is not really a recommended function, but there are cases where it can increase the speed of the queries. That's why I have included it. And another mention about speed is that the filter function is also not recommended to use, and it will slow the report execution by a lot. So if you have any other options than to use filter, then choose the other options. The last member we are covering today is date compare, and I have made a simple two datetime members or strings, and it's today and tomorrow. And this date compare function returns 1, -1, or 0, depending on which one is bigger. In this case, it returns -1 because tomorrow is bigger than today. But if I switch it around, then it returns 1 because it's the other way around. That the first one is bigger than the second one. So it compares the dates. Okay, date compare. So they're also going to be using current member, get property and item for the next MDX, and this is the one we also covered in the last webinar. I showed you the debugging, but I did not get into details about the functions. what this MDX query does, it returns one, the oldest unpaid invoice. So what is an unpaid invoice? An unpaid invoice is an invoice that has the invoice base balance. So it has some kind of balance that is not paid for. And in this query, the customer wanted to get also a MDX that shows invoices that are over the due date. So they're late for payments. And in order to check if they're late for payments, we have to check the invoice's due date and compare it to today. Let's see the oldest unpaid invoice date. And we also have to return the invoice's date. So here it is all together. And I debugged before, so I'm going to talk about the functions. In this case, we could only filter all the invoices, so the logic is that we want to check all of the invoices for this customer, right? We have a customer here in the rows, and we're going to take this customer and check this customer's all invoices and check if some invoices have invoice base balance. And okay, invoice base balance, and if the invoice has any invoices that are over due date. Let me go to the dashboard. There was another report overview, and this is what I showed you a little bit before with the invoice due date. Right? So they have property invoice due date, and you want to use this to check if the invoice is late for the payment. Right? So let's start with the filter. So filter takes a set expression and a logical expression. In this case, the set will be this, the non-empty cross joint, because the non-empty cross joint also returns a set. So in the non-empty cross joint, the set would be all the invoices for this customer. So it will try to combine customer with all the invoices and check, only pick the ones that have some kind of value between them. Somehow this makes the query faster. That's why I used the non-empty cross join, right? So now we are getting all of the invoices for this customer that we have in rows. This is the set we get for the filter function. Next, we want to get the logical. And the logical we have in two parts, because we have the AND statement. The first part, we check if they have any invoice balance. If the invoice has some balance that is not paid for. If they have any invoice balance, then we check if it's over due date. Right, similar to here, there's an invoice, that invoice base balance, and we're checking it's matched to May 30th, 2007. And we know that, for example, this invoice would ring true or return true for both of those statements, because we are checking if invoice balance is bigger than 0. So this invoice has the invoice balance bigger than 0, as you can see here, and the due date what is invoice due date, is equal 1, that means that today is bigger than the May 30th. So this invoice would be late for payments. So we want to get all of these for this customer, right? So I'm going to repeat that. We get all the invoices for this customer because they have some kind of values in between. Then we check if these invoices have any balance and if they are over due date, right? So now the filter will return a set, filtered out set with invoices for this customer that are over the due date. So they are late for payment, all the invoices that they are late for payment. And we want to use them in the order function. And order function takes a set, numeric expression, and ascending or descending. So the set is the list of invoices that we sorted out before. Then the numeric expression, interestingly enough, is the invoice due date. So we want to compare those invoices by their due date. For the invoice, I'm sorry, about the invoice date, because we want to get the oldest one. And we order them ascending, right? Order function takes a set, numeric expression, and how to sort it. We got the set from the filter with all the customer invoices that are over due date. We are sorting them by invoice date and ascending. And then we are getting the first invoice tuple, the first tuple, because the non-empty cross-join made a tuple, not just a member. So we are taking the first tuple, we are taking the first member from the tuple, which will be the invoice, and we are getting the invoices invoice date. I hope this was clear enough. And get is the same as get per property. It's very similar. You can also use string, get number. It just converts into the corresponding value, or it converts it to string, number, or whatever you need for there. Since I did not need to specify, I use just to get function. And here, all this unpaid invoice, you can see all these invoices that are not paid for. Is the dates for the invoices that are not paid for every customer. And that would be it for today.